Hi everyone. By request, we have a handful of questions to answer here. They're all from the McGraw-Hill Ryerson textbook for calculus and vectors. This is section 7.1 as well as 7.3. I'm gonna, off of my memory, I'm gonna write down the page. This will be page 384, 385, and 386, and then it's question 18 from there as well. And then we go back to 340 something, I think. This is section 7.1 from the textbook. I forgot the page number. But here we go. There's a couple of students, or rather, there's one student who have been getting small errors here and there. And judging from the answer key, it's all careless. But we'll go through a couple of them just to see where the mistakes could be, or common mistakes that can happen. And for anyone else who might be benefiting from this. Here we go. Calculating an angle between the vectors in each pair. Illustrate geometrically. Okay. Sorry about that. Let's do this. Section. Just drawing very randomly. Going to be very rough. 7, 8 is going to be somewhere there. That's going to be vector P. It's not very neat, is it? And 4, 3, 4. Let's see, 4, 3, somewhere there. Okay, I'm gonna pretend that is a Q. So judging from this, it seems like we're dealing with an acute angle, which is great. That's something that we need to keep in mind because we're dealing with the cosine. Angle. When we have position vectors and we're looking for angle, what first comes to mind is using the two vectors to calculate its dot product, and by definition, using its geometric formula, which links our magnitude and angle contained between together. Okay, so the dot product, let's do left side. Dot product is going to be the product of the x values, x vectors, plus the product of the y components, 28, 24, that's a 52. Next, we'll also need the magnitude of p, which is the by Pythagorean theorem, the base is a 7, the height is an 8, so we have 7 squared plus 8 squared equals hypotenuse squared, and so I have the square root. If I play that out, this is 49, 64, that's 113, 4, 6, 9, 4, yeah, 113. In the same way, magnitude of Q, I can pretend Q is the hypotenuse of a right angled triangle, which means the magnitude is the square root of 4 squared plus 3 squared. That's a Pythagorean triple. That's 3, 4, and 5. There it is. Therefore, putting it all together, we've got 52 is equal to magnitude of P, magnitude of Q, cosine theta, which allows cosine theta to be 52 divided by 5, 113. No need to rationalize. We are still in the midst of a calculation. Divided by 5, divided by root 113. We've got 0.978349. So keeping that exactly as is, I'm going to inverse cosine, giving me approximately 11.94, approximately 12 degrees. I think the textbook does say 11.9, so we'll leave it at that. Okay? Yeah, please be careful. I think there was a careless error in my student's response. Your 4, I think, was written as an 8. So small things like that. But as you can see, your process that you were going through was correct. Just be careful of the careless mistakes. We'll try number 6 now. We've got, ignore that. A factory worker pushes a package along a broken conveyor belt from -4 to 4 with a 50 Newton force at a 30-degree angle to the conveyor belt. Okay, geez. Visualize. Here's a conveyor belt. And, you know, conveyor belts, right? It's like a factory belt where things are being shipped along. Okay. Pushes a package along a broken conveyor belt from -40, oh my goodness, to positive 4, 0, with a 50 Newton force at 30 degrees to the conveyor belt. How much mechanical work is done if the units of the conveyor belt are in meters? Let me close my chat app. Okay. How much mechanical work is done if the unit conveyor belt are in meters? So I'm going to assume that my distance vector by magnitude is going to be 8. Right? I think that's fair. Another way you can do it is find the distance algebraically, find the vector from here to here by, let's call this point A to point B. Find AB by doing the subtraction of the x's, comma, subtraction of the y's. Right? Either way, I know what the magnitude is. Next, the force, the magnitude of the force is 50 newtons. If I'm interested in the mechanical work, by definition, work is going to be the force vector multiplied or dot the direction vector, which is also the same as the dot product. In this case, the magnitude of the force in its 30-degree direction is 50 times the distance magnitude is 8 times the cosine of 30 degrees. Plugging that into the calculator, I've got 400 times cosine of 30, which is 0.5. Wait, not 0.5, sorry. 1 over root 2. We've got approximately 346.4 joules. Okay, so this is just an application of the formula. Nothing more, nothing less. Here we go. Number 18. How much work is done against gravity by a worker who carries 25 kilograms up a 6 meter long set of stairs, inclined at 30. Okay, so it's a little physicsy, but that's okay. The only trick between the previous question and this one is that we're going up. Okay, if I am carrying a package, what force am I applying onto the package? Am I pushing it this way, or am I using my muscles to lift up? The answer is I'm lifting up. Okay? And now if my force is in that direction, I am also interested in the direction in that the direction in the upward direction. Right? Remember, work is the force times the displacement. But these two have to be in the same direction. Right? So when I'm walking, I am actually not interested in the left to right. My force is up and down. If I was interested in the work done from left to right, the vectors are perpendicular. My cosine would be of 90 degrees, giving me a 0. My work done is 0. And so if my force is this way, my displacement is that way, no useful work is done. I'm going to erase all that. Now, moving back, this time, how much work? It simply implies, because the horizontal work is by given, it's 0, you can assume the work they're asking for is specifically in the upward direction. So, force, distance. Well, distance is going to be 6 meters. Okay, 6 meter long set of stairs. Oh, wait. I should have looked at the answer key. I'm not sure if the question is talking about 6 meters this way, which then tells me I have to figure this out. I think it is. I think the distance is in fact this way. It is inclined at 30 degrees, which means my vertical and my distance is going to be 60 degrees contained between. With that said, remember my force is in the upward direction. Just what is that force? I am carrying a 25 kilogram newtons, so my force upwards is going to be equal to the force of gravity. This is very physicsy, and I don't blame you for not knowing if you've never taken physics. However, consider if someone is carrying a box, right, is this box falling to the ground? No. Force of gravity is there, but it's not falling to the ground because your biceps are applying an equal but opposite force to fight that gravity. Which means you are applying this force equal to the force of gravity, and that will be a dot product with the distance that you travel, so that I know how much work I am doing in the vertical direction. So let's see if I can calculate this. Here we go. Fg is mass times the acceleration of gravity, which is 25 kilograms, and I believe a lot of people who have been doing physics have been using 9.81. 9.8 is okay with me, but in any case, let's be a little bit more accurate, I suppose. 245.25 newtons. That is equal to my force in the upward direction. My distance, well, it is 6 meters. However, I am interested in the vertical direction, and so I'll just use this 30. 30 degrees opposite over hypotenuse. Sine of 30 is equal to my height, let's say, over my hypotenuse, which is 6 meters. The height that I'm interested in, or the vertical distance that I am traveling. Wait a minute. I don't care about that, do I? No, I don't. Sorry about that. Let me backtrack. We are doing a dot product. We're doing a dot product. So the formula in itself accounts for all that for us. My distance is 6 meters. Okay, so I have a vector, 245.25. I have a distance, 6. The angle contained between is that. What is the useful work done? Force dot distance, which is 245.25 multiplied by 6 multiplied by cosine of 60. And that gives us 245.25 cosine 60. 735.75 joules. Okay. I didn't get a chance to check your answer key from this question, but I hope that this clarifies and that it agrees with the back of the textbook. Moving on. These two questions actually I covered in class. I'm wondering if you can take a look at your notes first. I'll do it very quickly and see if you can come to a consensus with the answer key. A ship's course is set at a heading of 192, which means it's about, if I remember correctly, about there. Okay, and since north is 0, 192 means this angle is 12 degrees. South 12 degrees west, with a speed of 30 knots. A current is flowing from a bearing of 112. So from, if this is 90, 100, 112, somewhere around here, that means water is going to, the current is going to that direction. So if that's 112, that would be 22. So this would be 22 degrees, 14 knots. Use Cartesian vectors to determine the resultant vector of the ship. Okay. Ships, Cartesian is, I don't know where that is, but by definition, if you remember a Cartesian vector, it's the magnitude of the vector, cosine, angle from the horizontal. Okay, and magnitude of the vector, sine theta. But please remember, this vector happens to be in quadrant 3, which means both x and y values are negative. Okay. Next, we have current. Once again, it is the magnitude of the current, which is 14, times cosine theta, where theta is the angle with the horizontal, and then we have magnitude of the current, sine theta, where theta is the angle with the horizontal. But since this is in quadrant 2, you know that the x value has to be negative. In this way, using cast rule, we can keep to the simple angle of 22 instead of considering all of this as 158. And that should be it. Use Cartesian vectors to determine the resultant velocity. The resultant velocity would be adding the x's and adding the y's together separately. That becomes the resultant, and that's the end of the question. So try that and see if it agrees with the back of the textbook. Lastly, number 16. An airplane is flying at 550 at a heading of 80 degrees. The wind is blowing at 60 kilometers from, once again, from a bearing of 120. Okay, so I'm gonna, once again, it's so much easier to visualize if you can sort of just sketch it out. So that's what I'm going to do. It's a heading of 80, so it's gonna be something like that. Okay, and this is 10 degrees, 550 kilometers per hour. The wind is blowing from a bearing of 120. 120 would be about, 120 would be about here, but it's blowing from, so it's blowing this way at 60 kilometers an hour. And because that's a 120, that was a 30, this is a 30 degrees. Determine the ground velocity of the airplane. In other words, find the resultant. Because ground velocity is your plane relative to the Earth. So here we go. We can do this geometrically. Like we could do, okay, here is a 550 vector with a degree of 10. And then head to tail, I have a 60 kilometer vector. And this is 30 degrees. Parallel line theorem, the Z, letter Z. If that's 10 degrees, that's 10. So we have a triangle with a interior angle of 40. What is, from start to finish, what is that angle? So you could do it in a Cartesian manner by calculating your x's and your y's for each vector and then adding them together. Or you can use cosine law because you have side, angle, side, and you should be able to calculate your ground velocity. Since you're also interested in the angle, what you would do is using this, and since you would have that, you can calculate what that angle is. Right? You can if you can calculate that angle, you can also calculate this angle, because these three, this shaded area, theta plus 10 would equal 90 degrees. So once you have that angle, my resultant's direction would be north some degrees east. That should be the answer. See if you can try it. Hope this helps. Continue studying hard, and I'll see you tomorrow for the mini test. Good luck.